Okay, now let me deal with infinite decimal expansions. Okay, so what does this infinite decimal expansion mean? It means my numbers don't just stop, my numbers keep on going. Notice how all my question have a little line on the top. So number 23, basically this means 0.33333333. I repeat the 3 because the line is only over the 3. Question number 24, this is like 0.70, 70, 70, 70, 70, 70, on and on. I repeat the 70 because my line is over the number 70. If it was only over the 7, I only repeat the 7. Kind of like here, 0.7, my line is over the 7, so 0.77777777, on and on. Do notice the difference between 24 and 25. 24 is 0.70, 70, 70, 70. Now 25 is 0.7777. And then obviously number 26 will be 0.0707070707. Okay, before I look at how to do this, let me do something really quick. Let's say I had something like 0. I'm gonna come up with some numbers here. Let's say I had like 0.22222, and I multiply this by 10. Now that will give me 2.2222. Okay, so what really happened? Because I multiply by 10, I move the decimal one place to the right. Okay, but what if I had this number to begin with, but I multiply this by 100? Now I have 2 zeros. So just move the decimal 2 places to the right now. So that will give me 22.222. So you see what I'm doing? Like I move the 2 places. What if I multiply by 1,000? Right, 1,000 has 3 zeros, so move the decimal 3 places to the right, and so on and so forth. The amount of zeros is how many places to the right you move the decimal. So let's take a look at here. I'm gonna say that 1 times x, and I'm gonna say x is the number I'm trying to solve. X, as a matter of fact, is gonna be a fraction. 1 times x is 0. Let me give myself some space here. 1 times x is the same thing as 0.3333, and let's just say my 3 continues. Notice how I just said 1 times this fraction, because I want to write this as a fraction, is the decimal that I have. Now, because my number that repeats is only one number, then let me multiply this by 10. If I had that it repeated 2 numbers, I will multiply by 100, okay? Now let me multiply this by 10. So 10 times x, move the decimal 1 place to the right, and it will give me 3.3333 and a bunch of 3's. Okay, so let me just say that 1 times the fraction. X, once again, it's a fraction, is what I'm solving for, is the fraction that I need. 1 times x is 0.33333333, a bunch of 3's. 10 times x is 3.3333 and a bunch of 3's. Now let me subtract the top minus the bottom. And then I have an equal sign there. Okay. On the left side, 10x minus 1x. We know how to do 10 minus 1. That's going to give me 9x. It's easy. Interesting though, on the right side, my numbers after the decimal point cancel out. Because look, it's the same thing. I'm subtracting, so they cancel out. So here I'm looking at 3 minus 0 is 3. So 9 times x equals 3. To get the x by itself, let me divide by the number in front of it. So x is going to be 3/9. Nice. Now simplify. We know how to simplify. Let me simplify. Let me divide each by 3. So my answer is going to be 1/3. And remember, you guys type that 1 backslash 3. Nice. Let's take a look at question number 24. I have 0.70, 70, 70, 70. So I'm going to say 1x is 0.70, 70, 70, and it continues, right? Notice how I expanded my number a little bit. Now, because it's two numbers that repeat, I'm going to multiply this by 100. So 2 zeros. Notice how question number 23, I multiplied it by 10. Let me zoom out. I multiplied it by 10 only, but number 24, I'm multiplying it by 100. The difference why I have two different amount of zeros is because on number 23, it was only one number that repeated. So only 1 0. Number 24, I have two numbers that repeat, so 2 zeros. Okay, now that I have this, if I was to move my decimal 2 places to the right, that's going to give me 70.70, 70, 70, and a bunch of 70s. Let me subtract this. Here's my equal sign. On the left side, 100 minus 1, well, that gives me 99x. I know my numbers after the decimal cancel out, so that's good because I'm subtracting, so they cancel out. So I just have 70 minus 0. Well, that's 70. To have x by itself, let me divide both sides by the number in front of x. I'm going to say x is equal to 70 over 99. If you can simplify your fraction, by all means, do so. Right? Is there a number that I can divide 70 and 99 by to make him smaller? In this case, no, we cannot. So my answer is 70 over 99. Pretty nice. Let's take a look at number 25. I'm going to say that 1x is 0.7777, a bunch of sevens. Okay, I only have one number repeating, so let me multiply it only by 10. Now, by 10 gives me 7.777 and a bunch of sevens. Let me subtract this. 10 minus 1 is 9x. I know my numbers after the decimal point cancel out, so I'm just looking 7 minus 0. Let me divide by 9. Let me divide by the number in front of x. So my fraction is 7 over 9. Do simplify if possible. In this case, we cannot simplify. So I'm just going to call this 7 over 9. Cool. Let's take a look at my last example here. I'm going to say 1x is 0.070707 and a bunch of 07s. How far do you need to go? It really doesn't matter. Now, because I have two numbers that repeat, let me multiply this by 100, right? 2 zeros, because I have two numbers that repeat. So what does this give me? If I was to move the decimal 2 places to the right, it gives me 0.070707 and a bunch of 07s. Let me subtract this. 100 minus 1x is 99x. I know on this other side, the numbers after the decimal point cancel out. Now 07, like seriously, that's just 7, right? So I have this as 7 minus 0, so that's 7. Let me divide this by the number in front of x. So my fraction is 7 over 99. Do simplify if possible. In my case, I cannot simplify. So my answer is 7 over 99.